Good morning, students. This is Dr. Raghavendra Naveen, working as assistant professor in the Department of Pharmaceutics. So today we are going to discuss about the topic called as size reduction. So in case of the size reduction, so as per the course, so we are going to discuss about the various objectives, then the mechanism and the laws governing the size reduction, factors affecting the size reduction, principal construction, working uses, merits and demerits of the following mills called as hammer mill, ball mill, fluid energy mill, edge runner mill and end runner mill. What is the meaning of size reduction? So usually the raw materials, they will occur in the different sizes and that are very large, which can be used. Therefore, they must be reduced in the size, and size reduction is a process, so which will be carrying out to reduce the size of the bigger particles into a smaller one of desired size and shape. And whenever it comes to like a size reduction, so we can able to see here. So this is like a basic mills where we will be having rotating blades which will be rotating in opposite direction, and we will be having a provision for the hopper where we will pour the feed, and the feed will be get crushed between the two rotating rollers, and we can able to see the particles within a reduced size. And with respect to the pharmaceutical manufacturing, so size reduction is one of the most vital unit operation. So where we can able to reduce the large solid unit masses into a more number of the particles. And size reduction, so will be having some various objectives. So like to increase the surface area. So if you are reducing the size of the particle, so it will ultimately increases the surface area, and this increase in the surface area so will be enhancing the solubility aspect, and that can ability be finally increase the bioavailability. And size reduction, it also produces the particles in a narrow size range, and the stability of the suspensions and emulsions, so greatly it will be depends upon the particle size of the globules or maybe the particles. In case of the suspensions and the emulsions, in case of suspensions, the rate of sedimentation is largely depends upon the particle size, and in case of emulsions, the cracking and the creaming stability aspects or relating with the size of the particles or the globules. So if you are able to control or reduce the particle size, so which have the more chances to increase the stability of the suspensions and the emulsions. And apart from all this, whenever it comes to like an ophthalmic preparations or maybe for the external applications, we need to avoid the irritation whenever we are applying to the particular area of the skin. So if there is any particles which are having a greater particle size, so it may cause for the irritation or maybe some rough texture to the prepared dosage forms. And the rate of absorption is also depends upon the particle size. Of course, it might be ultimately depends upon the route of administration, and the physical appearance of the ointments, pastes and creams, so which can be improved so by reducing the particle size. And these are the like a few different objectives so for the understanding of the size reduction. So with respect to all these things, so size reduction is one of the most vital unit operation in the pharmaceutical preparation. And next we will be going to the different mechanisms of the size reduction. And usually the size reduction so will be happens with the two different methods, so precipitation method and the mechanical method. And in case of the precipitation method, So the ingredient, so that will be adding to the some solvent, and next that solution we will be adding another counter solvent, and that will forms in a precipitate, and that material will be having a reduced particle size. And this precipitation method, so usually we will be following in the chemical process, and the mechanical method where we are going to make use of some mechanical force like the application of grinding equipments or ball mill or colloidal mill, and so we will be reducing the particle size by different milling equipments. And advantage of the size reduction, so whenever the size reduction, the objectives are already discussed, and all the objectives of the size reduction can be interlinked with advantages. So contain uniformity, uniform flow, effective extraction of the drugs, and effective drying, and increase in the physical stability, and improved dissolution rate, and improved rate of absorption. So these are the different advantages of the size reduction. Of course, each and every process will have some drawbacks. So the drawbacks of the size reduction, so with respect to the contamination, so there might be some possibility of the contamination as the material is going to expose, or that will be coming in contact with the various equipments, and even apart from the contamination, so there might be more chances for the thermo liability. So during the process of size reduction, so there might be some wear and tear mechanism, and the solid particles or the active pharmaceutical ingredient, if they are unstable at the high temperatures or maybe the high pressures, there might be more possibility for the drug degradation. And coming to the mechanisms of the size reduction, so there are various mechanisms of size reduction called as impact, compression, attrition, and cutting. And in case of impact, so the particle size will be reduced by a single rigid force that we are calling by with the help of some hammers. And in case of the compression, so the material will be get crushed by the rollers by the applications of the some pressure, so that we are calling as in a compression. And in case of attrition, So the attrition will be arising from the particles, and that will be scraping against one each other, and the cutting, so the material will be get cut with the help of the some sharp blades. And whenever it comes to like a selection of the crusher or maybe the grinder, so the mill should have a very good capacity, and it should able to work within a small power input, and it should able to yield the product of single size. And factors affecting the size reduction. The first, the factors related to the nature of the raw materials, like hardness, fibrous, friable nature, elastic or sticky nature of the material, its melting point, hygroscopic nature, solvent and thermoliability. And in case of the other factors like purity, how much purity that we are expecting, and the flammability, the particle size and the moisture content. And whenever it comes to like the nature of the raw materials, so hardness, so sometimes it will be very easy to break the soft materials than compare with a hard materials. And the best example will be like an iodine. So iodine is very easy to break and it is a very soft material, and for that if you are making use of the hammer mill, so that will be enough. So like this, so we need to select the mill on base of the nature of the raw materials. And fibrous, so if the material is fiber having in nature, so then it will be very difficult, and there it will be bit difficult to process for the size reduction. So at that time, so we need to make use of cutters, so rather than the mills. Examples like some Zinzer and Rolfia. So these are materials which are tough in nature, and they are very soft, and which will be very difficult to handle. And next, fiber. So brittle substances which can be easily converted into particles like sucrose. So the mechanism, if you are making use of like attrition, impact and pressure, so it can be done with making use of some smaller mills. And other factors like elastic and sticky nature. So some substances, so they will become soft or they will become sticky while it is in a milling process. So like synthetic gums, waxes or maybe the resins. And even the low melting point substances, they may get melt when they are going for the size reduction process. And for this kind of materials, so we need to make use of some colloidal or fluid energy mill. So why? Because the lower melting point substances, so there will be continuous supply of the cool water, so that we can able to avoid the melting of the active pharmaceutical ingredients. So next point is a melting point. So some substances like waxy substances, fats and oils, so they will get softened just because of the heat that is generating in the size reduction process. And hence, so rather than making use of conventional mill, so we should making use of the mill which are having the jacketed vessels to supply the cool water. And some materials like which are hygroscopic, so they will become wet whenever they are going within a milling process. So at that time, so we need to protect the material so that it should not get exposed to the moisture. Solvated, so some substances, so they will hydrate or they will liberate the water during the milling process, and sometimes they may cause for the clogging of the mill. So like this best example will be the sodium sulfate. And some other factors, so apart from these raw materials, there are some other factors like thermoliability. Some certain substances, they may get degraded by the hydrolysis or maybe the oxidation process, and because of the presence of the moisture or maybe the atmospheric oxygen. And at this time, so we need to make use of the closed systems. And even for the same, we need to make use for the vitamins and the antibiotics, as they are thermoliable in nature, and that can be done by making use of the fluid energy or maybe the ball mills. And other factors which are affecting for the size reduction, so purity, so how much purity that will be required. And some substances, whenever they are exposing to the various mills, so they might be causing for some contamination. So that's why, so if you are expecting a good purity, so then it will be suggesting to go with a fluid energy mill. So like all these kind of factors that will be affecting for the size reduction. And related to the flammability, so some substances may have this flammability in nature, and related to the governing laws and the other mechanisms of the size reduction that we will discuss in the next class. Thank you.